Hey y'all. Okay, so let's continue with our 13.5. Let's look at this fourth problem right here. I know that in order to do a difference of squares problem, they need to both be squares and they also need to be, it needs to be a difference problem. So this is actually a sum, which means automatically we can't do this, okay? Literally, right there. That plus sign means that we can't work on this problem. Okay, so I believe this might just say not factorable. Possibility, it might say prime, but I would usually just say that this is not factorable, okay? We can't do difference of squares because that's a sum of squares. We do not have a formula for sum of squares. And mathematically, you can't do anything to it as far as factoring is concerned, okay? So now let's go ahead and look at this fifth problem. I'm trying to find my paper. There we go. Fifth problem. We're going to do this the same way we did the other ones. I don't just have that leading term with a variable squared. There's an actual coefficient here, but that's fine because we're still going to go about it and solve it the same way we solved the other ones. And the way we're going to do that is let's identify our a squared is 49x squared. Okay, I know that I'm going to take the square root of a squared. Sorry, I was reading, which is 49x squared. I'm trying to think, of course, in my notes, like I skip steps and stuff. Okay, so sorry. So I know that we're going to take the square root of a squared, and a squared is 49x squared. I know that I learned that exponent rule, which states that you could raise a base to a fractional exponent, and what you do is this is your denominator, and then your exponents, right? That's a 1 and a 2. 49 is raised to the first power. It's invisible, but all bases without exponents you could write as being raised to the first power. So what I'm going to do is those exponents are your numerator, and then our root is our denominator, right? So what I'm going to do, it just ends up being a couple of steps, y'all. This is more than one term. Well, that's not what I wanted. This is more than one term. I've got a coefficient and I got a variable, so it's slightly different than what we did before. I'm actually going to put it in parentheses, and then I'm going to raise it to the 1/2 power. And this is coming from the fact that it's being put underneath the square root. And now I'm going to use that exponent rule, where if you have multiple terms inside of the parentheses, everything would get the power that it's being raised to. And if you notice here, going back into this form, sorry, that's a little kind of dark, right? Going back into this form right here, just meaning that it's underneath the square root. Because this is with a fractional exponent, this is actually saying that 2 is my root and 1 is my exponent, right? Whoa, I'm sure y'all saw that. It's 49. So I could actually take the square root of 49, and then right here, we multiply our powers, right? I get x, 2 times 1/2 is 2 over 2. The square root of 49 is 7. X to the 2 over 2 becomes just x, okay? Technically, what we did is we took the square root of 49 and we took the square root of x squared, okay? There's literally probably an astronomical amount of combinations that you could take to solve this and to just actually get to 7x. Okay, so that is my A, correct? Well, let's go ahead and do the same thing to our B squared. My B What happens? My b squared is 16. I know I need to take the square root of b squared, which is 16, and the square root of 16 is 4. That's my b. Okay, so let's go ahead and put our template. Our a is what goes in front right there, and our a is our 7x. I do not care which one's negative or which one's positive. And then I think my laptop's fixing to die. Let me plug it in real quick. Okay, there we go. I don't know if y'all could see that, but my screen just got all dark. And then my b goes right here, and my b is 4, and that's your final answer. Y'all, if you go back and FOIL this, 7 times 7 is 49. Signs are the same, so it's positive. X times X is keep and add. If you continue with your FOILing, the two middle terms end up canceling, and then we would just have 4 times 4 is 16. Signs are different, so it's negative. Okay? Okay, so let's do this 6th problem, and then I'll need to do the last 2 on a different video, okay? So I want y'all to notice here that that leading term is not, it's not just squared, it's being raised to the 4th power, but I'm still going to go about it the exact same way. I just really need to pay attention and make sure that I look at the different forms of each factor, like once I start factoring things, and I'll show you why, okay? So let's go and do like we've been doing. Our a squared is actually y to the 4th. I know I need to take the square root of a squared, which is y to the 4th. I know that I have that exponent rule, which states I can do y, raise it to a fractional exponent. This is numerator. My root is denominator, right? And so if you do 4 divided by 2, you just get 2. This is my a. Now, if we look at our b squared, just the actual value is 2041. I know I need to take the square root. I'm sorry, what? 2,401. I know I need to take the square root of b squared. And what I get here, use your calculator, you'll get 49. This is my b. Let's go ahead and open up a set of parentheses. Does not matter. My a is y squared. My b is 49. Okay, but if you look at this right here, you wouldn't be done yet. Do y'all see why you're not done yet? That's a sum of squares, right? Can't do anything with that. What is that second factor? Square, square, difference. I'm actually going to do the difference of squares again, okay? So now I'm going to do this in a different color because this is what I'm looking at. So here my a squared is y squared, taking the square root of y squared. I've done it a couple times, y'all, okay? It's y. And then my b squared is 49, taking the square root of 49, I get 7, right? So that's my a, that's my b. Let's go ahead, bring down that first factor to your template, and then my a is y, my b is 7. Now that's your final answer. If you went back and you foiled these, that wasn't what was supposed to happen. You foil these two together, you will end up getting this, and then you foil these two together, and you end up getting this. Okay, so I will do a video for problem 7 and problem 8. And if y'all have questions, make sure you ask. Thanks. Bye.